This lesson is on acid and bases. So we'll start off with acid. What is an acid? This is the definition of acid, a substance which produces hydrogen ion or H+ when dissolved in water. So when acid dissolves in water, hydrogen ions are produced. Okay, an example of acid would be HCl. This HCl actually is hydrogen chloride. It is a gas. Now when this gas is dissolved in organic solvent like alcohol, this HCl exists in HCl molecule like this. Even at a gaseous form, it is in molecule form. When it is dissolved in alcohol, it will still remain in molecules form, H and then Cl combined together. So in organic solvent, the acid will not produce hydrogen ion. When this HCl is dissolved in water, it will dissociate. That means the H and the Cl will split up to produce the hydrogen ion as well as the chloride ion. Okay, it will become H+ and Cl-. Okay, if we look at the particle diagram, this is HCl in gas form, hydrogen chloride. It exists in molecule, 1H, 1Cl. They share one pair of electrons, so they are very stable. When they dissolve in water, they will split up to become H+ and Cl-. So this is a very important behavior of acid. When acid dissolves in water, they would produce hydrogen ions and whatever ions that it has. Okay, in the case of nitric acid, when nitric acid dissolves in water, it would produce hydrogen ion and nitric ion. Okay, so in the case of HCl, when you dissolve in water, it will split up to H+ and Cl-. For other acids like nitric acid, same thing. When you dissolve in water, you produce hydrogen ion, and in this case it's no longer chloride ion, it would be nitrate ion. Okay, now acid, the types of acid, we have naturally occurring acid or organic acid. An example of organic acid would be citric acid. Now citric acid is a weak acid. Weak acid meaning that it would dissociate or ionize less easily to form hydrogen ions. That means when citric acid dissolves in water, some of the citric acid exists in molecular form, but some of them would ionize to produce hydrogen ions. So some exist in molecule form, some become ions. Now contrast this with manganic acid or mineral acid. So manganic acid or mineral acid, an example would be hydrochloric acid. And hydrochloric acid is a strong acid. Why? Because when hydrochloric acid dissolves in water, it would dissociate or ionize easily to form hydrogen ions. Meaning that when HCl dissolves in water, almost all of the HCl molecules will not remain in molecule form like this. In fact, most of the HCl molecule will split up or dissociate to form hydrogen ion and chloride ion. So this is called strong acid. Strong acid means that most of the substance will become ions when it dissolves in water. Okay, so HCl is a strong acid because most of the HCl molecules, when dissolved in water, when this HCl dissolves in water, most of the HCl molecules dissociate or ionize to form H plus and Cl minus. Likewise, for nitric acid, it is also a strong acid because when nitric acid dissolves in water, almost all of the nitric acid molecules split up or dissociate to become H plus and nitric ion. Okay, very important distinction between weak acid and strong acid. What do you mean by weak acid? The definition is here. What do you mean by strong acid? The definition is here. The properties of acid, okay, taste sour, so all these are the properties should not be much of a problem. And when dissolved in water, the solution can conduct electricity, because when the acid dissolves in water, there will be ions, and it is because of the ions can carry charges, and because ion can carry charges, the solution can conduct electricity. Okay, these three are the main reactions for acid. The first one, acid react with reactive metal to form salt and water. Now this one I have to emphasize only for reactive metals, not for less reactive metals or unreactive metals like copper and silver. Copper and silver are unreactive metals. So acid plus metal, salt and hydrogen. An example of this type of reaction would be acid HCl plus a reactive metal, for example magnesium is a reactive metal, to form salt. So how do you know the name of the salt? The name of the salt must be two parts. The first part is a metal or ammonium. So in this case the metal is Mg. The second part of the name of the salt is a negative ion. So in this case is chloride. And of course MgCl, Mg is group 2, so it forms a Mg2 plus ion. Cl is group 7, so it forms a Cl minus ion, and then you cross multiply and then you can get MgCl2. So MgCl2 plus hydrogen gas, and then after that you have to balance the equation. So I guess it's balanced ready. So this is an example of acid plus reactive metal to form salt and hydrogen. Okay, the second reaction that involves acid is the reaction of acid with carbonates to form salt, carbon dioxide and water. Okay, and an example of this, salt, acid and carbonates. Acid HCl, carbonate, so something carbonate, for example calcium carbonate, CaCO3, calcium carbonate, and then it will form salt. Salt, the first part of the name of the salt must be a metal or a positive ion. Ca is Ca in this case, so CaCl2 plus carbon dioxide plus water, and then you can balance it, and this is the balanced chemical equation for acid and carbonate. Acid and carbonate to form salt, carbon dioxide and water. Okay, the third one is the reaction between acid and metal oxides and metal hydroxide. So metal oxide and metal hydroxide are basically base. So this is actually the reaction between acid and base to form salt and water. Acid and base to form salt and water. For example, an example of acid, again HCl. Base, an example of base would be, for example, magnesium hydroxide. It's a base. And then you get salt, MgCl2, salt and water, and then after that you can balance the equation. Okay, you can take your time and balance it. Okay, acid and base, salt and water. Now you need to know how to test for the presence of carbon dioxide. So basically is you just bubble the gas through the lime water, and when a white precipitate is formed in the lime water, that means carbon dioxide is present. Same thing with hydrogen. You need to know how to test for the hydrogen gas. So basically what you do is you put a lighted splint into a test tube containing the gas to be tested, and if the lighted splint is extinguished with a pop sound, the gas is hydrogen gas. So that basically all you need to know about acid.